In December 1941, the Imperial Japanese Navy unleashed a mechanical Leviathan that broke every known rule of naval architecture. Built behind a wall of absolute paranoid secrecy, she was a steel behemoth weighing over 70,000 tons. Her main gun turrets were so absurdly heavy that a single one weighed as much as an entire American destroyer. To this day, she carries the largest, most devastating naval artillery ever bolted to a ship's deck. Her name was Yamato. On paper, the Yamato was the ultimate system override, a super battleship specifically engineered to wade into a fleet of American warships, absorb their heaviest blows without flinching, and vaporize them with a single broadside. Yet, the defining clash of the titans she was built for never arrived. Instead, her story ends in one of the most apocalyptic non-nuclear explosions in human history. How did Japanese engineers construct this floating fortress? What were the hidden hydrodynamic tricks that allowed 70,000 tons of steel to outrun smaller ships? And why did the ultimate battleship become the ultimate martyr? To understand why the Yamato existed, you have to look at the cold, hard, industrial mathematics of the 1930s. Following the First World War, the Washington Naval Treaty of 1922 placed strict limits on the size of global navies. Japan was furious. The treaty officially restricted their fleet to just 60% of the strength of the American or British navies. For proud Japanese naval officers, it was a humiliating public insult. By 1934, Japan walked away from the treaty. They knew that if war broke out with the United States, America's massive assembly lines would easily outproduce them. Japan couldn't win a war of attrition. So, they adopted the Kantai-Kessen doctrine, the decisive fleet battle. If America had more ships, Japan would build the ultimate ship. They needed a vessel fast enough to chase down the enemy, armored like a bank vault, and carrying guns so massive they could outrange and obliterate American battleships before they could even return fire. The design principles were simple. Beat the American maximums. Japan calculated that US battleships couldn't go faster than 25 knots and couldn't mount guns larger than 16 inches due to the physical width restrictions of the Panama Canal. So, Japan aimed for 27 knots and a mind-bending gun caliber, 46 centimeters. But the Japanese Navy was terrified that the West would find out and build their own super ships. So, they instituted a masterclass in deception. Official documentation labeled the Yamato's main armament as the 41-centimeter, 16-inch special type. It was a deliberate lie. In reality, these barrels were nearly 70 feet long. To fire a single 18.1-inch armor-piercing shell, which weighed 3,218 pounds, roughly the weight of a modern family sedan, required 6 massive bags of cordite propellant weighing 727 pounds. When the Yamato fired a full broadside, she threw 60,000 pounds of steel downrange every minute, capable of punching through 19 inches of solid armor from 12 miles away. The muzzle blast was so violently destructive that the forward deck had to be stripped of normal structures. Otherwise, the shock wave would physically rip them off the ship. But bolting massive guns to a ship is easy. Making 70,000 tons of steel move at 27 knots is an absolute hydrodynamic nightmare. Brute forcing it with larger engines would burn through fuel reserves instantly. Japanese engineers needed a highly efficient hull. They tested over 50 scale models in a Tokyo water tank until they perfected a shape that belonged more to a sleek racing yacht than a bulky warship. The teardrop hull. At the waterline, the Yamato featured a long, sweeping, teardrop-shaped bow that tapered sharply, combined with a squat stern. This maximized the waterline length, manipulating the interference of the waves washing along the hull to drastically reduce drag. The chisel prow. To prevent the heavy bow from burying itself into rough Pacific swells and washing water over the guns, the prow flared dramatically outward, providing immense reserve buoyancy to keep her head up. The massive bulbous bow. Hidden beneath the waterline was the ultimate drag reduction trick. The massive bulbous protrusion created its own wave ahead of the ship. At cruising speeds, this artificial wave perfectly canceled out the ship's natural bow wave, allowing the Yamato to glide cleanly through the ocean, saving a staggering 15,800 horsepower in engine load. To survive combat against 16-inch American guns, the Yamato couldn't just have armor added to her hull. The armor was the hull. Engineers constructed a massive, heavily angled armored citadel, essentially a highly reinforced steel bathtub enclosing the ship's engine rooms and powder magazines. The protection was absurd. The side plating consisted of 16 inches of face-hardened steel, angled sharply to deflect incoming rounds. The armored deck roof was up to 9 inches thick, capable of bouncing shells fired from 20 miles away or stopping a 2,200-pound bomb dropped from 10,000 feet. Totaled up, the Yamato's armor alone weighed 22,900 tons, accounting for nearly a third of the ship's entire weight. It was as heavy as 2 fully loaded Liberty cargo ships. Inside this steel fortress, the ship was divided into 1,147 watertight compartments. Even if her unarmored bow and stern were completely flooded by torpedoes, the Yamato was engineered to remain buoyant and stable, capable of fighting on even while listing 20 degrees to one side. Despite being the deadliest machine on the water, the Yamato was surprisingly luxurious for her 3,000 crew members. While sailors on standard Allied warships suffered in the suffocating, oven-like heat of the South Pacific, the Yamato featured dedicated air conditioning systems that kept the living quarters and powder magazines cool. She was so spacious and comfortable, and kept out of the fighting so often to preserve her as a secret weapon, that ordinary Japanese sailors mockingly dubbed her Hotel Yamato. But her ultimate asset was up in the towering pagoda mast, the 15-meter optical rangefinder. While the U.S. Navy embraced advanced radar-guided targeting, Japanese radar tech lagged behind. Instead, Japan relied on world-class optics. Operating this massive rangefinder, technicians fed trigonometric data into complex mechanical computers that calculated precise firing solutions, staggering the barrels electronically so the massive shells wouldn't collide mid-air. The Yamato was an engineering masterpiece, but she was built for a world that had quietly ended. By April 1945, the decisive fleet battle doctrine was dead. The era of the battleship had been violently superseded by the aircraft carrier. American forces were landing on Okinawa, just 400 miles from the Japanese mainland. In a final, desperate gesture, the Yamato was loaded with every shell she could carry and sent on a one-way suicide mission, Operation Tengo. Her orders were to beach herself on Okinawa and fight until she was destroyed. She never made it. On April 7, 1945, the Yamato was ambushed in the open ocean by waves of nearly 400 American carrier-based aircraft. With no air cover of her own, the giant was hunted down. She absorbed punishment that would have shattered any other ship on Earth. 10 torpedoes and over 15 heavy bombs smashed into her hull. Blazing with fire and taking on thousands of tons of water, her list became critical. In a desperate, fatal move to keep the ship level, commanders deliberately flooded the starboard engine rooms, instantly drowning the hundreds of crewmen working below. But the flooding couldn't stop the inevitable. At 2:23 p.m., the pride of the Japanese Navy rolled over. Seconds later, as the fires reached her massive forward magazines, the Yamato detonated. A blinding pillar of fire tore the 70,000-ton Leviathan into fragments, sending a mushroom cloud nearly 4 miles into the sky. Nearly 3,000 men vanished in an instant. The ultimate battleship had managed to shoot down just 10 American planes. Before the war officially ended, the Japanese military ordered every blueprint, photograph, and technical document of the Yamato to be burned. They tried to erase her from history. Today, she rests split in half on the floor of the East China Sea. She remains the absolute pinnacle of battleship design, an astonishing triumph of hydrodynamic engineering, structural armor, and raw firepower. She was simply built for the wrong war.